everybody. Bringing Sarah on up here. And we got Dr. Wake. Hello, hello.
Hey.
And we should have Neha. Oh, there she is, Neha.
Yeah. Hello.
All right. How's it going, everybody? Thank you so much for coming to one of the last talks of the day. My name is Hitner. I am the Vice President of Strategic Partnerships at MatterHackers. We are honored to be a platinum sponsor of TYPE. This has been, can we just get some virtual, explode the room with gratitude for the TYPE team and the Women 3D Printing team for putting together this conference. It's like a feat of engineering in itself. And it's been incredible for everybody. Real quick, for those of you who are not familiar, MatterHackers, how did I get to be moderating this panel? MatterHackers, we're the largest retailer of budget-friendly desktop 3D printers and materials, and many of which you will see in these presentations today. So if you go to MatterHackers.com, you'll see we carry everything from the $300 Creality kits to the engineering-grade Ultimaker, MakerBot, WellsBot printers, up to $10,000-ish. And over 2,000 different types of filament and material. So we work with schools and companies and people with Etsy shops and government agencies and hospitals. And we match them up with the right 3D printers and materials for their use cases. Speaking of which, let's get into some use cases. I'm going to introduce our amazing panel. We have Sarah Rimini, who is the program director at the 3D lab at Geisinger Health. We've got Dr. Nicole Wake, who is the director of 3D imaging lab in the Department of Radiology at Montefiore Medical Center in New York City, my hometown. And we have new friend for me, Neha Sharma, who is a maxillofacial surgeon, and she runs the 3D print lab at the University Hospital in Basel, Switzerland. So before we get to the slides, surprise panelists, I was very, very inspired by the keynote this morning when we got to hear a little bit about everyone's career journey. And even if it means we don't get through all our slides, which I hope we can, I was hoping we could just maybe start with how did you get here? How did we get here? Maybe we can start with Sarah and just give us a quick minute or two how you got here today, and then we'll jump into the use cases and the slides. Cool?
Okay. Yeah, sure. Kind of just talked about this, but I don't want to overdo it. But I started in the medical field. I started as an X-ray tech and then moved into MRI. And then we started a 3D imaging lab here where we post-process the on-screen images. And then we went right from that into 3D printing since we have the background in the medical segmentation and design. And since then, and we've developed this program, I figured we have the medical side nailed down. We got to get some more engineering background. So I'm currently enrolled in Penn State's Master of Engineering in Additive Manufacturing and Design. So
I admire that about you. Always learning, always trying to get new skills.
Obsessed with learning.
Which is great.
Yeah.
Dr. Wake, a few words about you and your career trajectory.
Sure. So I did my PhD at NYU in biomedical imaging in the MRI physics department, and we had bought a 3D printer to make custom-made housing for MRI coils to hide the electronics, and I started using that for anatomic models during my PhD at NYU. I still have an adjunct appointment there doing 3D printing research, studying different types of materials, and I moved on to run the lab at Montefiore. So I run the clinical 3D printing and imaging lab there now, doing 3D printing and imaging clinically and for research and education.
Amazing. I can't wait for everyone to see what you're doing in the slides. Neha, you want to say a little bit about how you got here?
So I'm a maxillofacial surgeon from India, and I moved to Basel, Switzerland, mainly because of the research interest, and I knew that a 3D print lab has been established over there, and in 2015 I moved here. So it's been a 5-6 years journey with the lab, and the lab in the hospital is very exciting because it's actually run by the surgeons and radiologists. So basically we are all clinicians working together who are all passionate, and that's what we have been doing till now.
Awesome. All right, I'm going to share the screen and get some slides on up. Here we go. We're going to go crazy and start at slide 1. How's that? All right, so first up, Sarah, we're going to come right on back to you, and I am going to be your slide monkey here. So just when you're ready for the next slide, just give me a little next slide, and I will advance you.
Sounds good. Yeah. So this is just kind of the use cases for our lab. It's pretty, high level, but pre-surgical planning, surgical simulation, staff, resident, and patient education, as well as some surgical aid tools. You can do next slide. Yep. And then I just want to share some cool things with you guys. We do all of the medical models, but then what else are we doing? So we're doing a lot of 3D printed molds for education and simulation. This was one of my first ones. So this is a traumatic leg wound, and it just shows, we did a CT afterwards, and it shows the layers that are the same as the patient. So that's kind of cool. But next slide. This is one of my most recent ones. This is a skull phantom for radiography students, so they can learn how to position and do skull work better. They can shoot as many times x-ray at it as they want and learn the actual positions before they try and radiate the patient. Next one. This is kind of cool too. This is overlaying wall thickness analysis maps on skull patients that are undergoing craniosynostosis surgery, like reconstructions. So these are pediatric patients that have the fissures in their brain fused together prematurely, and then their skull won't develop any further, which means their brain won't develop any further. So they have to go back in and cut certain areas. Our surgeon likes to know, like, what are the thickest and thinnest areas that they need to stay away from, or geared more towards. So this was kind of nice that we can overlay this data. And then that one on the right is just showing how small some of these skulls are. These are, just newborn babies as well. Next slide. Maybe. Or is that it? There we go. My last one is just some surface scanning that we're starting to do. So for pediatric bereavement purposes, we can scan the patient's hand, a pediatric patient that might be passing away, and provide that model for their family to just help them cope better. That's just another area that we're getting into. I think that's all mine.
Well, I'm going to ask you a couple of questions. First of all, this last one, the multicolor printing. We don't. I don't know if everybody quite knows how that happens and why that's when solid one color printing is good enough, and then when you need multicolor printing.
Yeah, so we have all different, we have 4 different print technologies in our lab, and they all complement each other. We don't have to do all of these crazy colors all the time. Sometimes it's sufficient to just do like a white skull. But for the surgeon, and this one, especially those 2 on the left there, that's the same patient, that's both sides of their skull. So this is showing them information that they can't get even from the 3D model. And you can see the more red it is, the thinner the skull is, the green, the thicker it is. And then we also mapped it out with, the range of millimeters that color coincides with, so they can see a substantial difference in the one side versus the other. And it's kind of like almost like a topology map for some. So if I want to cut this skull in half, where am I going to avoid? Where should I make sure I have to cut down further? How deep do I have to go? That kind of stuff.
Yeah. And then you and I were talking a little bit more about this bereavement project that you're starting. You mentioned in your last talk that this is a topic that's uncomfortable for humans to talk about. Yeah. And yet there are a couple of projects that I've seen that are really really trying to make a difference, and specifically using 3D printers and 3D labs in hospitals to connect that patient care on this level. Can you talk a little bit more about that?
Yeah, so that's why we kind of said it's caring beyond medicine, because this is afterwards. And I mean, for this kind of stuff, this happens. We don't like talking about it. Nobody likes to think about this stuff, but this is something that's happening. And what can we give these parents that are not walking out of this hospital with their child? We can give them something. So not only can we give them a model of whatever they want, their hand with a stand or names, data, anything they want on it, but we also are going to be giving them the files, so that if multiple people want this model, or say something happens along, down the road and it breaks, they can still get a reprint of that model too.
That's amazing, and it's such a uniquely additive manufacturing thing. to be able to do, to have that file and then be able to reproduce it anywhere, literally anywhere in the world in different kinds of materials.
Yeah, it's crazy because our internal website for 3D printing went live, and then we didn't know anything about this. We didn't contact them or anything, and Child Life saw it, and they were doing the plaster castings, which almost all the time don't take correctly, or there's air bubbles, and they kind of got involved that way. So it was a neat little way that they got us.
Such a great use case, and such a great use case for like technology and materials that are here now and are reliable and are tested and are good to go. They're not still in that experimental phase. Awesome. All right. Next we have Dr. Wake.
Yeah, so thanks for having me. I run the 3D lab at Montefiore, and our lab is dedicated to provide 3D image visualization and 3D modeling, including AR and VR and 3D printing in support of patient care, education, and research. And you can just see some of the 3D visualizations, segmentations, quantitative image analysis, 3D printing in AR, VR, and simulation stuff that we do on this slide. Next, please. And so in regards to 3D printing, we have a material jetting and binder jetting industrial printers. And then we have some smaller units. So we have vat photopolymerization and material extrusion capabilities as well. Next. Recently, the lab actually was transformed to print PPE and other COVID-related items, mostly done on the smaller desktop machines. On the top left, you can see a couple of the face shield headband prototypes that we made. And then we use the Ultimaker desktop printer for that, the S5. And on the right-hand side, you can see some other models. We had ventilator parts and nasal swabs, and those we printed on our NextDent 5100 so that we could sterilize them. And you can see a picture of the lab, which was totally transformed during COVID at the bottom there. Next, please. And as compared to our typical workflow, which is shown here, that was really different. Typically, we go from the radiology imaging exam and create patient-specific models by segmenting that data, doing CAD modeling, and finally picking the printing technology we want to use. And that will depend on the type of model and what we want to do with it and printing. Next, please.
So the right tool for the right job.
Yeah, absolutely.
Very much alive.
And there are so many different technologies, and within each technology, so many printers to choose from, materials to choose from. So I'm just going to go through a few examples here. So this was a pelvic sarcoma case, and it was a 49-year-old female with a large tumor in the left hemipelvis, and you can see it in the middle on the 3D print or the 3D CAD model, and then we printed that in the Ultimaker using the two colors, white for the pelvis and then pink for the tumor, which you could see through there, through the holes. Next. This was another case that we printed on the Ultimaker, and you can see I like that pink filament. It was a patient with a large breast tumor shown on the left in the imaging and the segmentation, and then the CAD model in the middle, and again on the right-hand side is the printed model. And for that model, we actually printed a smaller scale model on the right-hand side showing the actual breast with the tumor so that the surgeon could get an idea of that relation. And they said it really helped to guide. They did an arterial embolization, so you could see the artery like coming down first, and then they did the complete surgical resection. So it was like a two-stage surgical approach that this model helped for. Next. And so this was a kidney cancer case that I recently printed. It was a patient with tuberous sclerosis and had two renal masses shown here in the CAD and the 3D printed model in the middle, and then on the right, one mass shown in green and another mass shown in pink. And this was something that we tested lattice structures using the binder jetting technology so that we could see those internal structures and lesions using that technology. So that's something exciting I've been working on. I don't know if you can see, I have it right here in the in the video.
Nice. Oh my goodness! When we're done with the slides, we'll definitely get a nice close up of that.
Love it.
Love me some shows. This is fascinating to me.
Yeah, and so I'm really excited that we now have Category 3 CPT codes for 3D printing, and while it's not full reimbursement, it's a pathway to obtain full reimbursement for printed models. So we have 4 codes that were released in July of 2019, 2 for anatomic models and 2 for anatomic guides. And you can go through your hospital billing system now, and if you have proper documentation for the orders and the printing of the models, then you can try to send them out for payment. So category 3 codes are codes for new technologies. They're not permanent codes, but we can use them to gain evidence that 3D printing is widespread across the United States and the world, and that it has high impact in patient care. Next, please. Oh, yeah.
This is more of the, I'm just curious, so this is more of the research phase?
Yeah, so it's research phase right now. So each hospital clinically can apply through their insurance to get payment, and we're also doing research to study like which use cases should be used. Like maybe like a kidney tumor, like the one I showed you, might warrant a model, but one with like a tiny little tumor on the edge of the kidney that any surgeon could easily operate on might not need a model. So we're working on things like that.
How much of a game changer is full reimbursement going to be for hospitals that want to bring this technology in-house?
It's definitely a huge game changer, because right now individual departments or hospitals tend to fund this. There's limited, funding. People apply for grants to support it. A lot of institutions might get the hardware initially, but they don't necessarily have funding to pay for it over time, to pay for like the staff to run the printers, or the, people to do the segmentation, or the material costs as you go along. So I think having that reimbursement will definitely help facilitate like more hospitals to be able to take this on.
It's great work. People talk about blockers like, oh, the machine's not ready, oh, the materials are not ready, but like there's other processes and legal things that we need to address as an industry.
Absolutely. So this is just a little vignette that I want to show that goes along with the code. So for a kidney tumor model where I have the cortex, the tumor, the artery, the vein, and the collecting system, that would be a 5-part anatomic model. Next. And you can see the CAD design showing those 5 parts on the left, and the 3D printed model we printed in material jetting using the Stratasys series there. We could bill for that using the 0559T code, which is the first anatomic part, one time, maybe for the kidney as the main part, and then using the 0560T 4 times for the remaining structures. So that's just how we would bill that out. Go on to the next one. And in conjunction with these codes, the RSNA 3D Printing Special Interest Group, which I am currently the secretary for, in conjunction with the American College of Radiology, has established a 3D printing registry. So hospitals or anybody doing 3D printing can sign up to be a part of this registry, and you can enter cases to show how many you do and what types you do and what printing technologies you use, things like that. And then we can use that data in the future to support an application for Category 1 codes to get that full reimbursement. So we're really excited about that. If you haven't heard of it, I encourage you to join.
Awesome. Thank you so much, Dr. Wake. We're going to go on to Neha for now, and then we are going to open up for some questions. We have until 2 o'clock, so we are doing good on time. Please put your questions in the Q&A, because sometimes they get lost in the chat. Obviously, I can make up questions if nobody has questions, but it is way more interesting if we take your questions. So please put those questions in the Q&A tab. All right, go for it. Yeah,
My turn, right? Okay, next slide, please.
Good direction.
Yep. So yep, I come from Basel, Switzerland. I plan to have this visual because most of the conference people are from USA, and I was thinking about maybe they should have a glimpse about the small city in the northwestern region of Basel, Switzerland. Yep. Next slide, please. And we are situated, this 3D print lab is situated in the University Hospital Basel. It is one of the largest centers in northwestern part of Switzerland with more than 50 to 60 clinical specialties. And the idea of a 3D printing lab here was to have it in a close proximity to the operating theater and also to the radiological and the CMF department. Next slide, please. And when I joined the lab, it was something like this. So we basically had a couple of desktop printers, FDM, and SLA printers. And from here, the journey actually began. Next slide, please. Yep. And within a couple of years, we expanded to a little bit of bigger area, actually 3 times than that one. But again, the issue was sometimes not only acquiring the 3D printers and the facilities, but also the space within the hospital, which should be close to the operating theater and the clinics. Next slide, please. Yep. And the lab actually doesn't only cater to the CMF region. We also collaborate with specialties like orthopedics, neurosurgeons, trauma, and also dental department. And sometimes we also print some artifacts or the toys for kids, like a small dinosaur over there. Yep. So we try to keep it fun over there. And like Nicole explained, the 3D printing workflow, it's the same. It starts with the CT data, and then the segmentation and all the planning is done. Yep. Next slide, please. Next one, please.
So
if we come to the area of maxillofacial, this is something that we commonly use. We use FDM printers to have anatomical models, and one of the benefit is to have these bending of the standard implants. Usually the implants for the surgery, they come and bending it inside the OR time, it's usually time consuming. So we plan to pre-bend them, and we can take the sterilized implant into the OR, and which adapts to the patient defect or the fracture site perfectly. So it's a way of predictable to have 3D printing and predictable results. And definitely education and training models are an important section for us, because surgeons usually learn more by haptic feedback. So having the haptics is usually important with the 3D models. Next one, please. Yep, again, we have started with this residency training program also for the surgeons, and surgeons can practice reduction using a simple 3D printed model or also a simulated kind of a setup. Next one, please. And if we move forward to some SLA or POLYJET printing, this is something that we have devised. Instead of using the conventional workflow in which you have to take an impression and do the manual work, we go and utilize the intraoral scanning in small babies who have cleft lip or palate cases. And the idea is to, from the intraoral scan, we can print a feeding plate for the child. And the benefit is it's not only it's easier for the surgeon as well, but I feel that it's more beneficial for the child. Instead of having a impression stuck into the palate of the child, it's very discomforting. And using just a 20-second intraoral scan, we can easily have a feeding plate for the child. Next one, please. And in the surgical field, we use surgical guides, virtual planning, and the surgical guides are usually printed in biocompatible materials, in which we use either SLA or POLYJET printing for jaw surgeries or also for tumor resection surgeries. Next one, please. And the common dental applications are, we can use dental models, and we can also use some guides, implant dentistry guides, and also the Michigan splints for sleep apnea or bruxism cases. We can all print these with using 3D printers. Next one, please. And this was an interesting case that we had. It was a footballer who just sent us a request that he wants something 3D printed. It's actually a professional footballer who was fascinated with 3D printing. So what we did, we only had his scan data and the x-rays. So what we did, we merged the CT scan data with the face scan, and we printed a patient-specific face mask for him.
I love this one because it branches out to different industries and introduces 3D printing into different industries with specific applications.
Exactly.
So much more interesting.
He wanted to look cool, so his request was he needed something with a scary and a black kind of a thing.
Doable.
Yeah, doable. Another interesting application that we use 3D printing is for having these hybrid customized implants. Why I call them hybrid is because they are standard implants, like which are available in the market in a flat shape, and we use 3D printing to pre-adapt or pre-bend these implants. Next one, please. And yes, we also had a case where we use actual 3D printed orbital plate for reconstruction of this kind of defect. Next one, please. And this is something that I like very much and in which I see a huge potential, where we have used 3D printing workflow. So designing from a CAD model, we have a 3D printed template in, and the implant that we use is through a molding technique. So it's a molded implant. And the next field that we are currently working on is, instead of having hybrid implants, what about if we have the customized implants fabricated in-house? So this is the project that I'm currently working on. Next one, please. And yeah, so the applications are diverse. We can use different kind of materials for different kind of regions, and we have different technologies. And one thing when I started, I was thinking about, okay, we have a 3D printer which can print something, but as I learned, I know that one tech cannot fit into each and every application. So we need to diversify and need to think about those aspects. Okay, what printing technology would be benefit for this kind of application? Next one, please. Yep.
Excellent.
Yeah, that's my time. Thank you so much.
Thank you all. Thank you all so much. And we have lots of time for questions. Neha, you mentioned using 3D printers for molds. And I think Sarah, if I remember correctly, you're doing some work in that area as well, yeah?
Yes.
She's an expert. I saw her lecture, I think so, last year with Nicole and Amy. And I realized that, oh my God, the silicon printing, silicon molding is high-end in your field. So I still remember that you recommended some YouTube videos over there and learn through that. And I'm still learning with that.
That's awesome. Thank you. Yeah, I mean, I kind of just got into that because our printers couldn't do, you know, as realistic of materials, and just dabbling in what we can do. And now getting into like the material properties and what shows up realistic on CAT scan versus MRI are completely different, and versus ultrasound, and just trying to get into all the nitty gritty of it now. So
I love how these seminars and these events, whether they're virtual or in person, they're helping the niche parts of these industries, you know, talking to each other if you're not already having those conversations. Mm-hmm. We do have some questions from the Q&A tab, so I encourage everybody, if you do have questions, definitely put them in the Q&A. The first one with the most upvotes: do any of you use virtual reality in your 3D print labs? And I'll actually add augmented reality to that as well, because I think both are used. Nicole, you want to maybe take a first stab at that one?
Sure, I can start. And we use both augmented and virtual reality as well as 3D printing. So right now for augmented reality, I use the HoloLens. And actually, some of my work at NYU, we have a study where we had patients with kidney and prostate cancer, and we showed the surgeons and the patients their models, either 3D printed or in augmented reality, and tried to compare how those, how the impact of those as compared to just regular imaging, talking to the patient with just the imaging, and then also how the surgeon better understood the anatomy, seeing the model in augmented reality or a 3D printed model. And actually for that study, we found that